To achieve familiarity with SQL, NoSQL, and PostgreSQL for querying databases and verifying data integrity during testing, you'll need to break down the learning process into key areas. Below is a guide for each technology, focusing on understanding the fundamentals, key concepts, and how they relate to database testing. 1. SQL, Structured Query Language. SQL is the standard language used to interact with relational databases, where data is stored in tables. Mastering SQL will allow you to verify data integrity and run queries to retrieve and manipulate data. Core concepts in SQL: tables, structured with rows and columns. Primary key, unique identifier for each record. Foreign key, links one table to another. Indexes, speed up data retrieval. Normalization, organizing data to reduce redundancy. Common SQL commands: select, retrieve data from a table. SQL select asterisk from employees. Insert data into a table. SQL insert into employees: name, position, salary, values, John Doe, manager, 50,000. Update, modify existing data. SQL update employee set salary equals 55,000 where ID equals 1. Delete, remove data from a table. SQL delete from employees where ID equals 1. Join, combine data from multiple tables based on a related column. SQL select employees.name, departments.department_name from employees. Join departments on employees, department underscore equals departments ID. Key SQL features for data integrity. Constraints, ensure rules at the database level, e.g., not null, unique, check, default. Transactions, group multiple SQL operations into a single unit, begin transaction, commit, rollback. Asset properties, atomicity, consistency, isolation, durability. SQL testing use cases, validate data retrieval using select queries, check data manipulation, insert/update/delete, operations. Verify table relationships, using join. Ensure the integrity of constraints like foreign key, unique constraints. 2. NoSQL, non-relational databases. NoSQL databases are used for large-scale, distributed data that doesn't fit the relational model. They are flexible and come in different types, such as document-based, key-value stores, column family stores, and graph databases. Types of NoSQL databases. 1. Document stores, e.g. MongoDB store data in JSON-like format, BSON in MongoDB. Flexible schema, which is useful when you have unstructured or semi-structured data. Example MongoDB query, JSON-db.employees.find, department, HR. 2. Key-value stores, e.g. Redis store data as key-value pairs. Excellent for caching and session management. Example Redis command, bash set employee, 1001 John Doe get employee, 1001 3. Column family stores, e.g. Cassandra data is stored in rows and columns, but rows are stored as key-value pairs, making it efficient for wide column stores. Example Cassandra query, SQL select asterisk from employees where department equals HR. 4. Graph databases, e.g. Neo4j store data as nodes and edges, making it perfect for highly interconnected data like social networks. Example Neo4j query, cipher match employee, dash, works under slash, d department, name, HR. Return key NoSQL features for testing, schemaless. No predefined structure, so testing involves ensuring data is stored and queried correctly. Horizontal scalability, ideal for distributed systems. Eventual consistency. Data consistency isn't guaranteed immediately, but becomes consistent over time. NoSQL testing use cases. Verify the integrity of unstructured data. Test CRUD operations: create, read, update, delete. Ensure data is retrieved correctly into normalized datasets. Check the consistency and availability of data in distributed environments. 3. PostgreSQL, Relational Database Management System. PostgreSQL is a powerful open-source relational database system known for its compliance with SQL standards, ACID properties, and support for advanced data types like JSON, arrays, and store. Key PostgreSQL features: rich SQL compliance, supports standard SQL commands, advanced data types, JSON, arrays, and store for semi-structured data, triggers and procedures, automate and encapsulate complex logic, foreign keys and constraints, maintain data integrity, indexes, advanced indexing like btree, gist, GIN for better performance. PostgreSQL query examples. Basic query, SQL select asterisk from employees where department equals HR. Insert data, SQL insert into employees, name, age, department, values, John Doe 29, HR. Updating data, SQL update employees set department equals sales, where name equals John Doe. Working with JSON, SQL select data name as employee underscore from employees where data dash department equals HR. PostgreSQL features for data integrity. Constraints, ensure that the data remains valid and consistent. Transactions, manage multiple operations with transaction control. Begin, commit, rollback. Referential integrity, enforce foreign key relationships. PostgreSQL testing use cases, ensure correctness of data retrieval, select queries. Verify that data modifications, insert/update/delete, conform to business rules. Test triggers, stored procedures, and views to verify their logic. Ensure complex queries like join, group by, and having returned the expected results. Test the integration of semi-structured data, like JSON fields, within relational tables. Database testing strategies to verify data integrity and accuracy during testing. You can follow these strategies. 1. Test data validation. Ensure that data in the database adheres to defined rules, constraints, null values, foreign keys. Verify that data transformations during CRUD operations are consistent with the expected results. 2. Query optimization and performance testing. Analyze query execution times and suggest index creation. Verify query performance using tools like Explain in PostgreSQL to check the execution plan. Test load times for NoSQL databases like MongoDB under heavy read/write operations. 3. Data integrity and ACID compliance testing. For SQL databases, test atomicity, ensuring that a set of SQL operations execute completely. Test consistency, ensuring the database moves from one valid state to another. Test isolation, checking that simultaneous transactions do not interfere with each other. Test durability, ensuring data is not lost even in case of system failures. 4. API integration testing. For both SQL and NoSQL databases, API requests can interact with the database. You should test that the API correctly performs the required operations, read, write, update, delete, and ensures that the database's state is accurate. Example, if the API writes a new user to the database, test that the record is accurately reflected in the SQL or NoSQL database. Tools for database testing, pgadmin. For working with PostgreSQL databases, dbeaver, cross-platform SQL client that works with both relational and NoSQL databases. MongoDB Compass, GUI for managing and querying MongoDB. JMeter for performance and load testing of databases. By understanding and practicing with SQL, NoSQL, and PostgreSQL, you'll be equipped to query databases, verify data integrity, and ensure smooth database operations in your testing processes.